All right, welcome to Next Gen Manufacturing. Today, we are pulling back the curtain on the unsung architect of pretty much every massive industrial project you can think of. We're talking about the hidden blueprint that turns a billion-dollar idea into a real, functioning facility. So, let's dive right in.
Have you ever done that? You drive by some colossal factory or a sprawling power plant with all its towers and pipes, and you just wonder, how in the world did that get here? That kind of mind-boggling complexity, well, it doesn't happen by accident. It's the result of an incredibly tough and often paradoxical process.
And that's where something called detailed engineering comes into play. You can think of it as the ultimate bridge between a cool concept and the actual construction. This is where every single plan, every schematic, and every little specification is meticulously created. It's basically the giant instruction manual for building the entire thing.
But here's the crazy part. This whole process is built on a fundamental contradiction, a real challenge that engineers have to solve every single day. We're going to call it the engineer's paradox.
Okay, so here it is in a nutshell. Logically, it makes total sense to design the heaviest, most complicated piece of machinery first, right? And then you design the structure that's going to hold it all up. But in the real world, you have to build from the ground up. You have to pour the foundation before you can put anything on top of it.
And this slide just lays out that conflict perfectly. Look at that. The logical design process on the left is the complete mirror opposite of the actual construction process on the right. So what does that mean? It means engineers are basically designing the end of the project before the beginning is even built. Wild, right?
So in the real world, this looks like making some seriously educated guesses. You're pouring concrete for a foundation based on preliminary load calculations. You're planning out entire pathways for cables before you even know exactly how many you'll need. You're ordering massive, expensive equipment that takes months to arrive based on estimated needs. It is, no joke, a high-stakes game of calculated risks.
And as if that whole paradox wasn't tricky enough, project managers are also caught in this constant tug-of-war. They're juggling four powerful and often completely contradictory demands all at once.
You see, managing one of these next-gen manufacturing projects, it's not just about being a brilliant engineer. It's about being a master juggler. You get one of these forces wrong, and the entire project can come crashing down. Okay, first up, the project deadline. This is almost always a fixed, non-negotiable date. Time is money, as they say, and the clock is always, always ticking. This one force dictates the pace of absolutely everything else.
Number two, the client's budget. And we're talking about the total cost for the entire project, from buying the land to flipping the switch. It is a hard financial ceiling, and every single decision has to be weighed against it.
Third, and this one is absolutely non-negotiable, is the technical quality. At the end of the day, the plant has to work, period. It has to be safe for the people operating it, it needs to run efficiently, be easy to maintain, and, ideally, be adaptable for whatever comes next. You just can't cut corners here.
And finally, number four, the engineering budget. This is the internal budget, the specific number of hours the design team gets to do all this work. If they go over, the project's profitability is at risk. So here's the kicker. You have to be fast, you have to be cheap, and you have to deliver world-class quality all at the same time.
So the big question is, how on earth do they manage this? How do engineers forge order out of what just seems like pure chaos? Well, the answer lies in a highly disciplined, rigorous process.
You have to imagine this environment. We're talking about hundreds, sometimes thousands of documents, all being created and revised at the same time by dozens of different people. Every tiny change to a pump could affect the piping diagram, which could then affect a structural plan. Without a rock-solid system, it would just be a complete mess. So the solution is this incredibly disciplined sequential flow of information. You start broad with general schemas, like how the product and energy will flow through the plant. From there, you move to layouts, defining the actual physical space. Only then can you specify the equipment, which then informs the civil plans, and finally, you get down to the nitty-gritty installation plans for every pipe and cable. Each step logically builds on the last, basically creating the entire project on paper long before the first shovel ever hits the ground. Okay, so you've got this amazing process, right? But documents on their own don't build a factory. This highly structured system is powered by a complex web of people, of human collaboration. It's a massive team sport. The engineering team is like the central hub, the quarterback. They're in constant communication with all these critical partners. You've got the purchasing department, who turns technical specs into actual orders.
You've got the client, who's constantly reviewing everything to make sure it aligns with their business goals. And, so crucially, you have the on-site construction team, the people turning the plans into physical reality and giving that vital feedback.
All right. This brings us to a really, really important point. One of the biggest pitfalls in any major engineering project. And it's a danger that, funny enough, comes from the very best of intentions.
It's the trap of perfectionism. See, at some point, a plan has to be declared good enough for construction, and then frozen. Constantly tweaking a design for tiny, minor improvements, it might feel productive, but it can create a massive ripple effect of changes that completely wrecks the schedule and blows the budget sky high. Sometimes, good enough is truly the perfect solution.
And this leads us to a final, powerful warning from our source material. It's always tempting to try and save money by hiring the cheapest engineering firm you can find. But as this quote makes so clear, those upfront savings are often just an illusion. You end up paying for it 10 times over during construction, or even worse, when the plant fails to start up correctly. Quality engineering isn't a cost, it's an investment in getting it right the first time.
So the next time you drive past one of those massive industrial plants, you'll know the incredible high-wire balancing act that brought it to life. And it really leaves us with a final thought, doesn't it? This tension, this fight between striving for perfection and the urgent need to just call something good enough so you can move forward, that's not just for engineers. It's a challenge we all face. Thanks for joining us on Next Gen Manufacturing.